Okay, so today we're going to be doing the last integration technique for the year. So remember, we've got U substitution, integration by parts, trig integrals, trig substitution, hyperbolic trig substitution, and finally partial fraction decomposition. Okay, so the stuff we do today and tomorrow, that will be the last thing for class test 1. Okay, remember class test 1 is just on the integration techniques. So after this week, next week, we've got one more integration topic that will be improper integrals. Okay, so please on the weekend, read up on that, improper integrals for next week. And then we will be done with the integration for now. And then after that will be applications of integration. Okay, so actually solving engineering problems and physics problems and that stuff using all of the integration we've done. Okay, so finding volumes of weird shapes, finding work done by forces on like weird curves in 3D space and 2D space, different things like that. Okay, so what is partial fraction decomposition? So we've seen a little bit of this before when we have integrating rational functions. For example, we had the integral 1 over x, 1 plus x dx. We had something like this, and we split it up into the two parts, and we did the integral being the log function. Remember that one? Yep. So we're going to be looking at things like this and more general more general integrals, where at the top for the numerator, we have some polynomial. So it won't just be 1, it will be some polynomial at the top. And at the bottom will be some other polynomial. Okay, so we generalize this to the idea of integrating p of x over q of x dx, where p and q are polynomials. Okay, so it won't be simple polynomials like this. They'll be quite a bit more complicated, but the idea is pretty simple. Now, just as a warning for this partial fraction decomposition, it does look like there's a lot of steps to do for each question. Okay, there are a lot of steps. However, each step is pretty simple. So you do step 1, then you do step 2, step 3, step 4, and so on. It's quite a lot of steps, but again, each one is pretty simple. Now, there's a very big problem with how these steps work out. If you mess up on step 1, then step 2 is wrong, step 3 is wrong, everything is wrong all the way down the ladder. Okay, so it is very, very important that you follow each step very carefully. Now, of course, I can give you part marks for the remaining steps, right, if you can do those, but you actually can't get more than like 50%. Okay, so if you mess up on step 1, you're already looking at a maximum of just 50%. Okay, just because how the steps go into each other. Okay, so please put a big warning there. You need to follow the steps very carefully. Okay. Especially the first step when we do the decomposition. Because if you split up this fraction the wrong way, everything just ends up very bad for you as you go further down. Okay. Okay, so let's get into this. So partial fraction decomposition. All right, decomposition. And then just on the side here, just put a little warning. So these steps only work when the degree of the numerator, so the p, is less than the degree of the denominator q. For example, a quadratic over a cubic, right? Because then the degree of the top is 2, the bottom is 3, then you can follow these steps. Okay, so it's like a step 0 type thing. We need to make sure that the degree of p is less than the degree of q. Okay, so just put the little warning on the side there. If that's not the case, so if the degree of the top is greater than or equal to the degree of the bottom, you have an extra step 0 that you need to do, and that's polynomial long division. Okay, we'll cover that later in an example. It's an extra step, but for now, just put the warning on the side there. So degree of p must be less than the degree of q. Otherwise, do polynomial long division. Okay. So you don't always have to do this. It's not part of the steps. But if you do see that the degree of P is greater than or equal to the degree of Q, you have to do that long division first before anything else. Okay. So it's like a step 0 kind of thing. Okay. So it's an optional thing just in case you do see that. Okay. Now for the step 1, for the actual decomposition. So step 1. Okay. This is split into 3 cases. So depending on what this bottom part looks like, this Q of X, there are 3 cases that we have to deal with. Okay, based on Q. P irrelevant. P can be whatever. Okay. Depending on that Q, you split it up into these 3 cases and you have to do something for each one. Okay, so case number 1 is when we have P of X over Q of X. And this is equal to P of X. Again, the P is irrelevant. We're only looking at the bottom. Over. Now for case 1, it's if this Q of X can be factored into linear terms. So the bottom will be AX plus B, dot, 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 maybe CX plus D. So you can factor that polynomial into some linear terms. Right, if it's quadratic, you'd have 2. If it's cubic, you have 3, and so on. If you can factor it like this, then you deal with case 1. Okay. So in the bottom, we have a product of linear terms. So case 1, the bottom part is a product of linear terms. Now, there is a theorem. We're not going to go through it or prove it. We're just going to use it. It says that if we have a rational function like this, where we have a polynomial at the top and a product of linear terms at the bottom, then we can split it up in the following way. So we have A1, which is just some number, over the first term, plus all the other terms look very similar. Up to the last one, let's call it AN over CX plus D. Again, that's a theorem that tells us we can do this. We're not going to look at it. We're not going to look at the proof. We know we can do it. We're just going to use it. Okay, so you just trust me. We can do this. Okay, so we can split it up like this. Okay, this is why we call it partial fraction decomposition. We've got a rational function or a fraction on the left, and we decompose it into a sum of smaller, simpler terms on the right. Yeah, that's the idea. Something complicated on the left, a sum of simpler terms on the right. Okay, so that's case 1, product of linear terms. Case 2 is if we have P of X over Q of X. Okay. Now, in this case, we still have a product of linear terms, but some of them are repeated. So they're not all different. Some of them are copies. For example, we can have this P of X over, maybe the first one is repeated twice. So we got 2 of them. So we can write it as AX plus B squared, right? Because there's 2 of them next to each other. We can write it as a square. Maybe the second term is repeated 3 times. So it would be CX plus D cubed, because we have it 3 times in the bottom. So first one, it's linear, but it's repeated twice. We got 2 of them in the bottom. The second one is linear, CX plus D, and it's repeated 3 times in the bottom. And however many we've got there. So dot, dot, dots, however many, up to, let's say, EX plus F. Okay, but they're all linear. That's the important part. And some of them are repeated. So for case 2, when some of them are repeated, it's very similar to case 1, but for each of the repetitions, we need to add an extra term. Okay, so what do I mean by that? So here, the first one is repeated twice. So we are going to have two terms for it. We're going to have A1 over the linear term, but it's repeated twice, so we need another term for it. So this will be plus A2 over AX plus B squared this time. Okay, again, you don't need to know where this comes from. We're not looking at that. You just need to follow, right, the rules for the different cases. Okay, so again, if it's repeated twice in the bottom, we're going to have two terms in the decomposition. One where it's linear, one where it's quadratic, like this. Now, for the next one, it's cubed. You can guess what we're going to do for that. It's going to be B1 over CX plus D. Then we're going to have B2 over CX plus D squared. Okay, so very simple rule to follow. And you can guess the next one. It will be B3 over CX plus D cubed. So it's repeated 3 times, and so we have 3 terms to go with it. Okay, plus all the other stuff, if it's repeated more, you follow the same rule. Up to that last one, that one is repeated once. There's only one of them. So we can say plus C over EX plus F. Okay. So again, please just underline this one here. So the first 2 is when it's repeated twice. So it's squared, we have 2 terms. Okay, one for it being linear, one for it being quadratic. And then the next one, we have it 3 times, one for linear, one for quadratic, one for cubic. If it was repeated 4 times, you'd have 4 terms, one for linear, one for quadratic, one for cubic, one for to the power 4. Yeah, and so on. Everyone get the idea for repeated linear? Okay. And then finally, case 3. So in general, there's more cases, but I'm not going to give you anything more than quadratic. So we're going to stop at this one. Okay. So the next one here, we have P of X over Q of X again. Again, the P doesn't matter. We're only looking at the Q. And now for the Q, we're going to have the case where it's an irreducible quadratic term. Okay, so what does that mean? Well, it's going to look something like this. We have P of X over AX squared plus B. Something like that, where this cannot be factored anymore. Right? Think of a very simple example like x squared plus 1. Right? We can't factor that, right? There's no x minus 1, x plus 1 that we can do. So x squared plus 1 is an irreducible quadratic term. Okay, so if we have something like that, then it's case 3. If you can factor it, then it will be case 1 or case 2, where it's linear. Does everyone understand that? Yeah. So again, for this, think of something like x squared plus 1, where you cannot factor it any further. And then maybe you have some other terms as well. Okay. And this we call an irreducible quadratic. Okay. Like I said, we're not going to look at cubics or anything like that. We're going to stop at the quadratics. Okay. In the tutorial, you might see a few cubic ones. We're not going to go that far. Okay. You get the idea from quadratic. Cubic is just more work that's not really needed. Okay. So a test and stuff, it will just be quadratic terms like this. Okay. Okay, so if we have an irreducible quadratic, what we do is we write it in the following way. Now the bottom part is quadratic. For the top part, we cannot use just a constant anymore. Okay, so if it was linear at the bottom, we could just put a constant at the top. If it's quadratic at the bottom, any guesses what we put at the top? No, not a quadratic. Just a guess. There's no reason you know what it is. So if it's quadratic at the bottom, any guess for the top? So someone said? Like from the pattern, what do you think? So the bottom here is linear, the top one is constant. If the bottom is quadratic, the top one will be linear. Yeah, it will be linear. So here the bottom is quadratic, so it will be something like, right? Do you see the pattern? Linear at the bottom, constant at the top, quadratic at the bottom, linear at the top. If it was cubic at the bottom, it would be quadratic at the top. Right? It just adds more work, so we're not going to be doing that one. So we'll stop here for the linear. So instead of just having a at the top, it will be ax plus b at the top. So here we have ax plus b over ax squared plus b. Okay. So if it's quadratic at the bottom, then the top needs to be linear. So we write it as ax plus b. Plus all the other terms that you might get. And then the last one, we see that's linear at the bottom. So we have a constant at the top. Let's call it c over cx plus d. Okay, so quadratic at the bottom, linear at the top. That's all you need to remember for this one. Okay, and again, you could go for the other cases where it's cubic at the bottom and so on, but I'm not going to test you on that. You'll see some examples in the tutorial. Do them just for practice, but it won't be in the test. Okay, any questions on these three cases? Okay. Okay, so for step one, you need to do this decomposition. So I give you this integral like this. You look at the P over Q, and then you need to pick which case to do. Okay, to split it up. Now the problem is, if you do the wrong thing here, now your decomposition is wrong. These constants at the top here are going to be wrong. Your integrals will be wrong. Your final answer will be wrong. Right? You see how it messes up all the way down. So it's very, very important that you do step one correct and you check that it's correct. Then you go to step two, step three, and so on. Okay. Any questions before we look at a couple examples? All good. Okay. So step one, and then we'll see step two with this example now. So step two, solving for the coefficients. Okay, so step one, this was the partial fraction decomposition. Okay. Step two, solving for the coefficients. So here for all of these problems, I put A1 to AN, all of those numbers. We need to actually figure out what those numbers are. Okay, and that comes with step two. Okay, so let's look at an example. So number one, we have x plus 5 over x squared plus x minus 2. Okay. So remember the step 0, we need to check if the degree of the top is less than the degree of the bottom. So degree of the top is 1, degree of the bottom is 2. So 1 is less than 2, so we can skip that step 0. Okay, now we need to try and factor the bottom. If we can factor the bottom, it's case 1. If we cannot factor the bottom, then it's case 3. Make sense? Okay. So the top stays the same, x plus 5. And the bottom, we see, can we factor it? Can we factor x squared plus x minus 2? See, this is why you must be very careful with the step 1. If you think you can't factor it, your decomposition's wrong, everything's wrong. Okay, so please check. Can you factor this? Yeah, we can factor it. What does it factor into? x minus 1, x plus 2. Very good. So it's case 1. Now, if you thought you couldn't factor it, now you're thinking it's case 3. You're doing something completely different. Case 1, case 3, right? So please make sure you know how to factor these quadratics and cubics. Okay. So we know it's case 1. We've got a linear term, x plus 2, and a linear term, x minus 1. So we can split it up into a over the first one and b over the second, like we did for case 1. So this will be a over the first one and b over the second one. Okay. Now, what are a and b? We need to solve for that. Now, there are two methods that I like for solving for a and b. We'll cover both of them in these examples. I suggest you pick your favorite one and stick with that. If you start going between different ways, you're going to mess up at some point. So we'll go through both a few times. Pick your favorite and stick with it. If you're going to do different things, you're going to cause problems for yourself. Yeah, so solving for a and b. So we're going to have x plus 5 over the factored bottom is equal to this decomposition. So x plus 5 over the bottom is equal to this decomposition. Now we're going to clear the denominator. We just cross multiply there. So we're going to have x plus 5 is equal to a x minus 1, b x plus 2. Okay. And this is where the two methods split up. So the first method is we are going to choose different values for x in a very clever way that we can solve for a and b. Okay, that's method number 1. Method number 2 is a bit more complicated. We'll do that later. So just put here method 1. Choose x values. Okay, method 2 will be setting up a system of equations and you solve it like you do in the MATH161. System of equations, all that stuff. It's that method. Okay. So in 132, it's not by itself. There's mixing, right? Stuff you do in 132, you do in 161. Okay, so this method, we're going to choose x values. We're going to choose them very carefully. The first x value I'm going to choose is 1. X equals 1. Now, why might I do that? If I choose x equals 1 to substitute, what makes that good to choose? It cancels out the a, exactly. So we choose an x value that will cancel one of the terms, and we can solve for the other. Now, for my second value of x, what would that be? Minus 2 cancels out the b. Okay, you get the idea? Okay. So there's a and b. There's two values, so we're going to choose two x values. If there were 3, then you would choose 3 x values, and so on. So let's x equals 1. So what happens? So on this left side, if x equals 1, we're going to get 6. And we chose it in such a way that the a goes away. Now we just have b, which will be 3b. So b must be 2. And we can do the same thing by getting rid of b by saying x equals minus 2. Okay, so on the one side, we're going to have a 3. And on the other side, we're going to have a minus 3 because the b goes away. So we get a equals minus 1. Okay, very simple. We get our a and b values. Now again, I'll warn you about the steps. If you make a mistake here and you get the wrong a and b values, when you then substitute back here, right, this is going to be wrong. Right, you're going to have the wrong coefficients in front. So you'll get part marks for the integration later, but you won't get any marks for the a and b calculations, right? Okay, so again, if you want full marks, every single step you need to check very carefully. Okay, otherwise you're just hoping for part marks at that point. Okay, so we've got those values, so we can substitute now. So x plus 5 over x squared plus x minus 2 is equal to, we can put the a value back in, so that's minus 1. And the b value was 2. Okay. Now we've done all of that. Step 3 would now be integrating this. But that's the goal. We want to integrate this. So step 3, integration. So the integral of x plus 5 over x squared plus x minus 2 will be the integral of this. But now it's split up. We did the decomposition, so we can just do each one individually. So we have minus the integral 1 over x plus 2 plus 2 times the integral 1 over x minus 1. So we get minus the natural log x plus 2 plus 2 times the natural log x minus 1 plus c. Okay. And again, I want to point out your part marks and all of that. So if we go right back to the beginning here, okay. Now let's say you didn't know that this could be factored and you just leave the denominator like that, right? You thought, no, this can't be factored. It's that case 3. So we're just going to integrate this. Well, now your a and b, you're not going to get, right? Because you wouldn't have factored it like this. So you don't get any marks for that. That's gone. Then you go down a step. So this is gone, right? You get the wrong a and b already. Then you go down and now you try and integrate this. Maybe you do a u substitution or something, but that's all gone now. Because integrating this without the decomposition, you can't do. That's gone. So you lose all the marks for that. So step 1, not knowing that you need to factor it, what do you get for this? 0. There's no part marks I can give you. You don't have the a and b. You didn't do the integral. You can't get anything. Now let's say a little better. You did factor it, but you couldn't solve for a and b. So you have a and b, but they're wrong. So what you can get is you can get the part marks for the integral. That's fine. But you won't get the minus 1 and you won't get the 2. So that's gone. Good. Did you see how the steps go into each other? Okay. So, please be careful with these problems. Any questions on this one? Pretty simple. Okay, let's have a look at another example. Okay, so here we have x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x. Okay, and eventually we want to do the integral of this. Now, first thing we need to do, that's step 0, is check the degree of the top and the degree of the bottom. So degree of the top is 2, degree of the bottom is 3. Okay, so that's all fine. We can skip that step 0. We go straight to step 1. So step 1, we need to factor that bottom part as much as possible and check what case is it. Is it case 1, case 2, case 3? Then we do the decomposition, we solve for the coefficients, and finally we do the integration. Okay, so let's factor that bottom part as much as we can. Top part, we just leave alone throughout. So we're going to have x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x. So first thing we notice in the bottom, there's an x common for all of them. So we can take the x out. So this will be x squared plus 2x minus 1 over x. Right? You don't have to do it all at once. You can factor it step by step. So we're going to take the x out. So we have left with 2x squared plus 3x minus 2. Right? Don't do too much at once. Step by step. So 2x squared plus 3x minus 2. Now we ask ourselves, okay, we got a quadratic there. Can that be factored? If it can be factored, we're looking at case 1, right? Where we have the 3 linear terms. If it cannot be factored, then we are looking at case 3. One linear term, one quadratic term. It's very important that we know if we're doing case 1 or case 3 here. Okay, so 2x squared plus 3x minus 2, can that be factored? Yes? Okay, good, good. So what are the factors for that? So we're going to have the tops being the same. Right, don't try to factor the top. That's not going to help you. It's always the bottom part. So it will be x and then something. What do we get? 2x minus 1. Very good. And? X plus 2. Good. Okay, so here we have 3 linear terms in the bottom. So it's case 1. So we're going to have something over x, something over 2x minus 1, and something over x plus 2. Does everyone see that? I hope so. So this is going to be something over the first one, something over the second one, and something over the third one. Okay. And now we have 3 things to solve for. In the previous one, we only had 2. Okay, now we have 3. I'm probably not going to give you anything more than 4. Okay, so solving for A, B, C, and D, that's as much as I'm going to put for the test. Okay. In the tutorial, one question goes all the way to R, and you have to solve for that. Okay, but for the test, 3 or 4, that's as much as I'm going to give you. Okay, yeah, so just keep notes on the side so you know what's coming. Okay, now we need to solve for these. So we can set these 2 ones equal to each other, cross multiply like we did before, and then we can solve. So we're going to have x squared plus 2x minus 1 over x, 2x minus 1, x plus 2, and then the decomposition we found here. Okay, so same as before, we do the cross multiplying to clear the denominator. So we're going to have x squared plus 2x minus 1. It's going to be a 2x minus 1, x plus 2, plus b, x plus 2, plus c, x, 2x minus 1. Right, that's just clearing the denominator. That's easy stuff. Okay, now at this point, I'm going to show you method 2. So method 2 is where we get a system of 3 equations, 3 unknowns, and you do your MATH162 stuff with it. Okay. Now, you can pick between the 2, or you can do a third method if you want. But like I said before, pick something you like and stick with it. If you're going to choose different methods for every second problem, you're going to run into issues later. Okay, so look at the 2 methods, pick one of them, and stick with it. Tutorials, quizzes, tests, just stick with the same thing. So what we're going to do now is on the right-hand side, we've got a bunch of brackets. We're going to expand everything out. Okay, so here we have x squared plus 2x minus 1 is a 2x squared plus 4x minus x, so plus 3x minus 2 plus b x squared plus 2x plus c 2x squared minus x. Okay, so all of that we have expanded out. Now I'm going to join all of the like terms together. So all of the x squared terms I'm going to put together, the x terms I'm going to put together, and the constants I'm going to put together. So on this side, we still have x squared plus 2x minus 1. And now on the other side, all the x squared terms I'm going to put together. So I have 2a from the first one. I have a b from the second one. And I have a 2c from the third one. Did everyone see that? All the x squared terms are put together. Okay, so the first bracket, I have 2a x squared. The second bracket, I have bx squared. The very last bracket at the end there, I have 2c x squared. Yeah, I'm putting all of that together into x squared. And we're going to do the same thing for x. So for x, I'm going to have 3a from the first bracket. I have 2b from the second bracket, and I have minus c from the third bracket. Okay, everyone still with me? Okay, and now the constants, I have a minus 2 from the first one, and that's it. Okay, so x squared terms are put together, x terms are put together, and the constant terms are put together. Okay, everyone see that? Okay, so now what I'm going to do, please use a bit of color in your books now. The coefficients of x squared on the left, I'm going to match up with the coefficients of x squared on the right. I'm going to call that equation 1. Okay, so green with green, equation 1, right, from your 132 stuff. Green with green, equation 1. Blue with blue, I'm going to call that equation 2. And finally, the last one, pink with pink, I'm going to call that equation 3. Okay, so please make sure you see the 3 equations there. So my set of equations is going to be 2a plus b plus 2c equals 1. That's equation 1. That's green. Next, 3a plus 2b minus c. That's going to be equal to 2. That's my equation 2. And finally, minus 2a and nothing else there. So minus 2a and minus 1. That's equation 3. Okay. So the color helps to identify the 3 equations and the 3 unknowns. So now we have a system of 3 equations and 3 unknowns. We can now solve for it, right? Like your 132. So you can use your row echelon form, your reduced whatever. You can use inverse matrices. You can use whatever you want to solve it now. Because it's a system of equations, you know several methods, right? On how to do that. So we have a system of 3 equations and 3 unknowns. Yeah. Now, at this point, I'll leave you to pick whatever your favorite method is, right? The reduced row echelon form, inverse matrix. What's the other one with the coefficient matrix? You do the determinant divided by the determinant. Yeah, I leave it to you. You pick whatever. You want to do your row substitution, you pick whatever you want. Okay. Okay, so a system of 3 equations, 3 unknowns. You know several methods from 132. You pick your favorites. You go ahead and do that. Okay. So again, I'll leave you. You do that for homework. Pick your favorites. Stick with it, please. Don't swap between things. But here we get a equals a half. B equals a fifth. And C equals minus 1 over 10. Okay, so you check with whatever method you want. You should get this as your answer. Okay, try a few different methods, see what works for you, but just double check that for homework. I suggest you pick something that is quite quick to do and quick to check. Because in a test, if you end up with something and then you spend 10 minutes getting A, B, and C, you check, right? You substitute back and you check, and you find it's wrong. Now you need to spend another 10 minutes redoing it. So I do suggest you try a few different ways that are quick to do and quick to check. Okay. It's no use spending 10 minutes finding your inverse matrix and then it's wrong, right? Okay. Okay, now that you have your A, B, and C, we can then substitute it back. So you substitute back A, B, and C, and you do your integration. So it will be natural log of x, 1/2 natural log 2x minus 1, natural log x plus 2. Okay, that's easy stuff. You know how to do that one. Okay, so homework, substitute back, and then finish off the integral. Okay, I gave you the coefficients, sub back, do the integral. Okay, any questions on this one? Yeah. The marks. Okay, so overall, the marks will be, okay, so this is assuming you don't have to do any long division. We'll see that in the next example. So for this one, maybe 2 marks for this. So factoring and then splitting up, 2 marks. And then this one over here, maybe 3, 4 marks. The solving for this. Right, setting up the system, substituting back, maybe 3, 4 marks for that. And then the integration right at the end, maybe 2, 3 marks, depending on the difficulty. Okay. So that's 2, 4, 8 to 10 marks in total. Yeah. Again, depending on the difficulty, this one, the integration was very easy to do. Later on, we'll see that integration is not always so easy. So it can be more than 10. So between 8, 12 marks, maybe something like that. Okay. The one for the class test is very easy. I'm just telling you that now. Do not stress for the class test. Very easy. Don't even worry about it. If you can do the tutorial, you're fine. Okay. Do not stress for the class test. The June test, stress. Okay. Because that's when I'm going to put the 10 mark one. Because I need to find like 75 marks for the June test. Putting one question out of 10, very easy, right? 10 marks already set. Okay. So class test, please do not stress. It will be very easy. June test, stress. Okay. Any questions before we move on? Okay. So that was example 2. Example 3 now. So for this example, I'll tell you right now, we have to do that step 0. But please, you always need to check the degree of the top must be less than the degree of the bottom. So I'm telling you for each one, but please, in the test and stuff, you have to check. I'm not going to tell you the steps to follow. Okay, so here we have the integral x to the 4 minus 2x squared plus 4x plus 1 over x cubed minus x squared minus x plus 1. And again, I keep telling you that's step 0. Here we're going to have to do that step 0 because the top part is a 4. The bottom part is degree 3. The top is not less than the bottom. So we have to do the step 0 before we get to the step 1 from the previous ones. So here, step 0. Polynomial long division. Okay, so I hope you all remember your long division from grade 3 or whenever you did it. So now we'll go through it again. Remember, it was something like this. We have like 3021 divided by 72 or whatever. And then your teacher said, how many times does 72 go into 3? And you put the number. How many times does 72 go into 30? You put the number, right? You remember that thing. We're going to do exactly the same thing. I'm going to say it exactly like your teacher said it, but instead of numbers, it's now polynomials. The idea is exactly the same. The setting is exactly the same. Yeah. So let's do that. So we set it out exactly the same here. So we're going to have x to the 4 minus 2x squared plus 4x plus 1 divided by x cubed minus x squared minus x plus 1. Right? So your top part, that goes inside the division, and then the bottom part, that goes on the outside there. Okay, now we go back to grade 3, and I ask you, how many times does x cubed go into x to the 4? X to the 4 divided by x cubed is not 1. X to the 4 at the top, x cubed at the bottom, that becomes x. Okay, please remember what you did with the numbers. If I have this here, what did we do? We did the 3 over this, and then the 30 over this, 302 over this. It was a division that we did each time. Exactly the same thing here. It's a division. It's x to the 4 over x cubed is x. But now instead of numbers, instead of like 7 over 3 is 2 remainder 1, it is now x. And what's the next step? We take the top thing, we multiply it by the bottom, and we put it underneath, right? So x times that side thing will then be x to the 4 minus x cubed minus x squared plus x. And then we had to subtract them, right? Everyone remember that? Yeah. So now we do the subtraction. X to the 4 minus x to the 4, that's 0. Next one, the x cubed. In the top, there is no x cubed, so it's a 0. 0 minus x cubed is x cubed. Minus 2x squared minus x squared is plus 3 x squared. Okay. Then 4x minus x is, so we're doing the subtraction now. So 4x minus x is plus 3x. And then what did we do after all of that? We did the carry. You remember the setup from grade 3 or whenever you did this? Okay, so you do the division, you multiply the top down, you do the subtraction, and then you do your carry. And then we do it again. Now, the question is, x cubed divided by x cubed is 1. Yeah, x cubed at the bottom. You look a bit lost. Right, we're doing this here. So the first thing was x to the 4 divided by x cubed is x. Now we understand. X cubed divided by x cubed is 1. So we put a 1 there. Yeah, so that will be plus 1. Yeah. Oh, yeah. Oh, minus x. Why did it put the limitation? Oh, yeah. Sorry, no, I thought that was a plus 2. Yeah. Yeah, thank you. So that'll be a minus, yeah. Yeah, so it's a minus 2 plus x squared, so a minus. Yeah, that's right. Which one? 4x minus x 3. Yeah, right there. Yeah. So we get the 1, and then 1 times that, we put it down in the bottom. Yes. Okay. Then we do the subtraction. So x cubed minus x cubed, that goes away. Minus x squared minus x squared, that goes away. 3x minus x, so that will be 4x. And 1 minus 1, that goes away. So we're done. So what would you tell your teacher? It would be x plus 1, remainder 4x. Right? So here you would write the answer as x plus 1, remainder 4x. Okay. So that's what you would write down. Now, what does this mean for the division? So let's rewrite it. So we have x to the 4 minus 2x squared plus 4x plus 1 divided by x cubed minus x squared minus x plus 1 is equal to. So we did the whole long division, and what did we get? We got x plus 1 and the remainder was 4x. So the remainder of 4x, what does it mean for the fraction? It means plus 4x over whatever we were dividing by. Right? So if I was doing 7 divided by 2, for example, you would have 3 remainder 1. But that 1 is 1 over 2, right? Because it's 3.5. So 3 remainder 1, if you're dividing by 2, is 3.5. So whatever the remainder is, we divide by what we're dividing by on the left there. So this is the remainder. Okay, does everyone see that? Okay, so please, if you're a bit uncomfortable with the long division, please do a few of those practice problems in the tutorial. Okay, this you're going to see quite a bit, especially over here, when you have a high degree at the top and a lower degree at the bottom, then you have to do this long division. There's no way around it. You have to do that step 0. Okay, so step 0 is done, and we can see that the degree of the top is 1, the degree of the bottom is 3, so everything's fine. We can now go to step 1. Okay, so step 1, we look at that bottom part and we factor it. Depending on how we factor it, it's either case 1, case 2, or case 3. Okay, and remember right at the beginning when I said this is a very long process, right, this is what I mean. So each step, is quite a bit of work to do. Okay. Okay, bottom part, we need to factor that. So it's a cubic. You know how to factor cubics. What do we get for the bottom? So top stays the same. Remember, top, you leave it at alone. So 4x over, and then we're going to have three factors at the bottom for the cubic. X plus 1, yep. And then the other two, x minus 1. One more. There must be a third one because it's cubic. Anyone want to guess what the last one is? Or if they know? So we got x plus 1, x minus 1. There's a third one. You have to know you're factoring cubics, right? Quadratics and cubics, you have to know how to factor these. Okay, I'll give you a bit of time and then I'll put the answer down. Yeah, it's not a trick or anything. There are 3 factors. X minus 1. Yeah, we get another x minus 1. Good. So the factors are x plus 1, x minus 1, and another x minus 1. So we should have 3 factors, right? It's a cubic, so we have 3 factors. But look at the x minus 1. We have 2 of them. Okay, so we have x plus 1, x minus 1, and x minus 1 a second time. So we can write this as 4x over x plus 1, x minus 1 squared. We got 2. So when we're doing the decomposition, we're going to have a linear 1 for the first one and a repeated linear 1 for the second. So it's case 2. Everyone see that? Yeah. So let's split it up. So we're going to have A over the first one, B over the second one, and c over the second one squared. Okay, again, it's that case 2. So for it being repeated, we have b over the second one and c over the second one squared. It's those two terms we need. Okay, everyone clear on that? Okay. So please do not write a over x plus 1, b over x minus 1, c over x minus 1. Right? It is not case 1 where you have a, b, and c. This is case 2. Okay, it makes a big difference when you're solving for a, b, and c. Okay, so please put a warning here where you have that squared. Okay, it gives us these two terms here, with the second one being squared. Okay, so we're going to now solve, yeah? X plus 1. That's the first term, the a over x plus 1. Sorry? At the top. Oh, the x plus 1 here. No, we leave that aside for now. We're just looking at the fraction. Yeah, at the end, we'll put it back. Yeah, maybe put a big star here so we don't forget that. Okay, so this we do need to add back at the end. But when we're doing the decomposition, it's only for the fraction. Right, it's partial fraction decomposition. It only works for the fraction. But yeah, we do need to add that back at the end. Okay, let's solve for the a, b, and c. So we're going to have 4x over x plus 1, x minus 1 squared is going to be a over the first one, b over the second one, and c over the second one squared. Cross multiply like we did before, and then we can solve for a, b, and c. So 4x is a, x minus 1 squared, plus b, x plus 1, x minus 1, plus c, x plus 1. Right, just cross multiplying, things cancel, and we end up with this. Now, we did the system of equations in the last example. Now we're going to do the choosing x values, right? Just to give you some practice for the two. So here, any guess for the first value of x? Someone said 1. Yeah, 1 was perfectly fine. That will get rid of the a term. It will also get rid of b. So we can then solve for c. Everyone see that? So if x is 1, we get rid of a, b, we can solve for c. So let x be 1. So we get 4 is equal to a goes away, b goes away, and we have 2 times c. So c must be 2. Now we need something else. Sorry, minus 1. Yep, that'll work. So if x equals minus 1, b goes away, c goes away, we can solve for a. Okay. So again, it's minus 1, so we're going to have 4a. Okay. Everyone see that? Okay. And then now we need a third one so that we can solve for b. Now it's not really clear what we can choose. 1 and minus 1 have been taken, so we just pick something else. Any ideas? You don't want to pick something like 10. You're just asking for trouble. So something very simple, we can just substitute. Any ideas? Yeah, it can be anything, right? Anything. We just want to substitute, but you don't want to pick something where you can make like addition mistakes or something like that. So what's a nice number we can pick? 2. Yeah, 2 will work. 0, that will work. You can pick anything. So let's try 2. Okay, so on the left side, we chose 2, so that will be an 8. Okay, then we have A. We know what A is. A is minus 1. X is 2. B, we don't know what that is, so we'll put B. And again, X is 2. And C, we know what that is, and X is 2. So that'll be 3. So we have 8 is equal to 2 minus 1 squared, that'll just be 1, so we have minus 1. Okay, very simple just to solve now. So 8 minus 6, so we have 2 on that side, add another 1, so we have 3. Okay. So just as a little side calculation, choose X to be 0. You should get the same thing. Okay. So if X is 0, you should still get B as 1. Okay, so this is step 2 done. Okay, we've got our A, B, and C. Now we can substitute it back to what we had before and then do the integral. So we're going to have the integral of all of this. So we can put the x plus 1 back. So x plus 1 plus, and then the decomposition. So that was the fraction parts after x plus 1. So it will be A over x plus 1. And we said A was minus 1. Plus, then we said B over x minus 1. And B is 1. And we go back a bit. Then we said C over x minus 1 squared. And we had here C was 2. Okay. And at this point, please do not mix up your A, B, and C's. So we said A for the first one, B for the second, C for the third. You need to keep that same order. Otherwise, you're swapping numbers around. Okay. Now we just do the integral. Easy stuff. So this will be half x squared plus x minus the natural log x plus 1 plus the natural log x minus 1 minus 2 over x minus 1 plus c. And you see how I just wrote the answer down? That's how you should be doing it, right? It's like 1 or 2 marks for that final line. You just write it out. You know how to do that quite easily. Sometimes it will be a bit more difficult. You'll get extra marks for that. But most of the time, you can just write out the answer like this. Okay. Any questions for this one? All good. And again, please remember the step 0 that we had to do. Okay. So the step 0 here for the long division, please do not forget that. If you just skip straight to the decomposition, it's going to cause lots of problems. Any questions before we move on? Okay, so for this next example, number 4, that last step of the integration is going to be slightly more difficult. Okay, not too much more difficult, but it's a little bit more thinking than just writing out the answer. So for this one, we have the integral of 2x squared minus x plus 4 over x cubed plus 4x. Always check your step 0. Degree of the top is 2. Degree of the bottom is 3. Okay, so we can leave out step 0 and we can go straight to step 1. Okay, so we have 2x squared minus x plus 4 all over x cubed plus 4x. We leave the top alone. Okay, we don't have to worry about that. But that bottom part, we need to factor it as much as possible. So again, we do it step by step. You don't have to do everything at once. X cubed and 4x, they share a factor of x. And we can take that out. Okay, now we have a quadratic and we ask ourselves, can that be factored? X squared plus 4, can it be factored? No, it cannot be factored. So that is an irreducible quadratic term. So this is now case 3. Okay, it cannot be factored anymore, so it is not case 1. We do not have anything repeated. It is not case 2. It is case 3. We have to do something different now. So this is going to be equal to, the first one is linear, so we just treat it as normal, a over x, plus, now this is quadratic at the bottom. So the top part needs to be linear, so it will be bx plus c. Okay. Again, please keep in mind which case you are dealing with. They are very different. Everyone clear on this step? Okay. Irreducible quadratic, so it's that case 3. Now, step 2, we need to solve for a, b, and c. Exactly the same as we did before. So we're going to have 2x squared minus x plus 4 all over x squared plus 4 is equal to a over x plus b x plus c over x squared plus 4. Okay, same as all of the other examples. We cross multiply, get rid of the denominator, and then you need to pick your method, right? How you're going to solve for a, b, and c. So cross multiplying, we get 2x squared minus x plus 4 is equal to a x squared plus 4 plus bx plus c times x. Okay, now for this one, you can choose the x values like we did before, right? You can choose x to be 0 or whatever, but this one is actually easier to do with that other method. Okay, so we're going to expand everything out and then compare the coefficients. Okay, again, you don't have to. You can let x be 0, you can let x be 1 and solve it that way. This other way we'll see is actually easier. So we have 2x squared minus x plus 4 is equal to, we need the x squared terms. So we're going to have an a and we're going to have a b. Okay. What about the x terms? We just have a c. And the constant terms, we just have a 4a from the first one. Okay. Then we have our green equation, equation 1. We have our blue equation for equation 2, and the pink equation for equation 3. So we're going to set up our system, and we'll see it's very easy to solve for a, b, and c. So equation 1, a plus b equals 2. Next equation, we have c equals minus 1. We have our answer already. And the last one, 4a equals 4. A equals 1, we have that already. Okay, so setting it up like this, we have our answer like right away. So it saves us a lot of trouble of substituting x equals 0, x equals 1, and trying to solve it that way. This way, we get it very, very quickly. Okay, so again, you need to see what works for you. Okay, so here we have a is 1. If a is 1, b must also be 1. And c, we have our answer already, is minus 1. Okay. So for homework, try it the other way. Substitute maybe x equals 0 and x equals 1. So you can solve for your a and b. Maybe it's easier, maybe it's more difficult. Again, it's up to you. You need to pick which way to do. So I'll just write that here, homework. Try x equals 0, x equals 1. So x equals 0, I chose that because the second term is multiplied by x. So if we say x equals 0, all of that goes away. And then we can just solve for a. X equals 1, I just chose that randomly. And then we need a final one, so maybe x equals 2. Okay, so homework, try it that way. See which one you prefer. Okay. Any questions before we move on? All good. Okay, step 3, the integration. So we have the integral of this decomposition, and now we know a, b, and c, so we can substitute that. So it's going to be 1 over x plus x minus 1 over x squared plus 4. Okay, now you need to listen very, very carefully to the next thing I'm going to say. That second term where we had bx plus c, always split it into 2 fractions. Always. Right? If you're not going to listen to me, you're not going to know how to do this. Always split it up. Last year, I said the same thing. You split it up and you do the integral. Students did not listen to me, and they put log for every single thing, and they got 0. Split up that second term into b and c. So this is going to be equal to the integral 1 over x plus the term with b, that's the x, and the term with c, that's the minus 1. So just as a very big warning here, so this happened last year, right? There's no guarantee it will happen this year, but just as a warning, the students saw that x minus 1 over x squared plus 4, and then this just became the natural log of x squared plus 4. I saw that in so many of the exams last year, because, you know, the top part, they ignored the top part, they saw the bottom part, and they just put natural log. Okay, but if you split it up, now we can clearly see what to do for each of them. The first one, the 1 over x, forget that one. So the second term, x over x squared plus 4, what can we do? Use substitution, exactly. And then the third one, the 1 over x squared plus a squared. Not. What is it? You can, but it's easier to do something else. 1 over x squared plus a squared. Arc10, yeah, we've done it so many times. Arc10. Okay, so again, you split it up and you can clearly see the 3 terms now. So if you just left it like that, you put the natural log of the bottom, you get nothing. So please do not fall into that trap of just looking at the bottom, putting natural log and moving on. Okay, don't do that. Okay, so let's move on. So integral 1 over x, that's the natural log. This one, we do a u substitution at the bottom. I'll let you do the details, but you end up with 1/2 natural log x squared plus 4 minus 1/2 arctan x over 2. Okay, so the u sub, I'll let you put in the details on the side. You should get that. Okay. Any questions for this one? All clear. Okay. And again, please, the warning about these terms here. Okay. Please make sure you listen. Because if you just treat it like this, even if you tried to do a u substitution with that term, so u equals x squared plus 4, right? du is 2x. But the top is x minus 1. And you think, okay, well, u sub doesn't work. I can't do anything, right? But if you split it up, you can see the first one is u sub, the second one is arctan. It's very clear what to do. So please split it up and then treat all of the integrals separately. Okay, we'll see in the test who listened. Any questions before we move on? Oh, good. Okay, next one. This is going to be the more difficult one, right? So this one won't be for the test, but maybe for the exam. So we have the integral x cubed plus x squared plus 1 over x minus 1, x squared plus x plus 1, and x squared plus 1 cubed. Okay, so we're not going to do the full integration and all of that. I'll leave you to do that. All we're going to do is look at the terms and think about all of the stuff we've learned today and try and split this thing up. Okay, then the rest you can do for homework. Okay, so let's try and split this up. Once it's split up, you know what to do from there. So the first one at the bottom is x. So what do we get? If there's just an x at the bottom, what term does that become? Someone said it? A over x. Next one, x minus 1. What does that become? B over x minus 1. Good. Next one. Not just C. It's an irreducible quadratic. Cx plus d. Okay, please think all of the stuff we've done so far. Next one, a little bit tricky. It's an irreducible quadratic, but it's repeated 3 times. So we're going to have 3 terms because of the repetition. It's also quadratic. So the top part is not just a constant. Right, so you need to put all the stuff together that we've done so far. So what do we get? Ex plus f over x squared plus 1. Good. So that's for the first repetition. Now we need for the second one. We can't use the same letters. It's all separate terms. So just follow the pattern. G. Or squared, exactly. That's for the second repetition. And now the third one. You're thinking about the next letter? Okay, please. Okay. I'd rather have the math confuse you than the alphabet. Okay. Okay, yeah. Ix plus j. Okay, otherwise make up something. Please don't think about what the next one's going to be. Yeah, ix plus j over? Or cube. There we go. Okay, good. Okay, so this will be like the most difficult that you're going to get. Yeah. So no cubics or anything, just up to quadratics. So here, just to summarize, we had the x, so a over x. X minus 1, b over x minus 1. Next one, it was an irreducible quadratic. It cannot be factored. So it will be cx plus d. The next one is a quadratic repeated 3 times. So we need 1 for the first one, x squared plus 1. We need another one for x squared plus 1 squared, and a final one for x squared plus 1 cubed. Does everyone see that? Yeah. This will be as difficult as it's going to get. I'm not going to go to cubic and all of that. Okay. So homework, continue the steps. So solve for a to j and then do the integration. Okay. Just a note, you're going to use all of your techniques that we've covered so far. Okay. For the integral. So the first 2, that will just be natural log, right? But this one, the x squared plus 1, you're going to have to complete the square and do a trig substitution. right? Okay, because we're going to have, let's say, cx over x squared plus 1, x squared plus x plus 1. You can't just do a u substitution. You're going to have to do some trig substitution there. Then the next term will be d over x squared plus x plus 1. You're going to have to complete the square and write it as an arctan. And then for the next one, ex over x squared plus 1, you're going to have to do a u substitution again because of the x over x squared plus 1. Then this next one here, you're going to do another u substitution because it's x squared plus 1 at the bottom and x at the top. And then finally, the last one, another u substitution, x squared plus 1 at the bottom, x at the top. So you see, every single term, you have something we've done before, whether it's a u substitution, a trig substitution, or the arctan integral. Every single term, it's something we've covered before. Okay, so now if you forget your trig substitution, now you can't answer half the question here. Okay, so again, way back I told you, all the questions have everything mixed. This is what I mean. You got u substitutions everywhere, you got trig substitutions mixed in here. Okay, so you have to know everything to answer it. Any questions for this one? Okay, so please continue from here. And then finally, the last one, number 6. So 6, you are doing entirely on your own. Step 0 all the way to step 3. So number 6, the integral of x cubed plus 4x squared plus x minus 1 all over x cubed plus x squared. Okay, so we've got something like this. So just treat it as something you would have in a test. So you have to do all the steps by yourself now. Okay, I'm not going to give you any hints or anything. Okay. Any questions for the final homework? Okay, so for the test, expect something like this for this last one. Okay, so we've covered every case, we've covered all the integrals. If you can do this number 6 using everything we've done today, you can do the test problem. Okay, it will be as difficult as this. Hint, hint. I don't know how many times I need to point at it, right? This one over here. Is everyone getting the hints? Okay, something like this. Okay, for the test. So tomorrow we are going to do rationalizing substitution. Please read that in the textbook. It's the very last thing in this chapter. Okay, so for Thursday, rationalizing substitution. Okay, so very last bit. It's like half a page in the textbook for the last chapter. Please read through that for tomorrow. So for these integrals, it's going to look like this. So notice in the bracket there, it is not x squared. You cannot do trig substitution for these ones. It's just x. So if it was x squared, you would do trig substitution or hyperbolic trig substitution. If it's just x by itself, we are going to use rationalizing substitution. Okay, so the way rationalizing substitution works is we're going to do a particular u substitution to convert this with the roots into something like this with a rational function. It's a way of getting rid of the roots. Yeah. Now, as I've said before, there's more than one way of answering these. You can use rationalizing substitution. You can use just the normal u substitution. That will be up to you to pick. Okay. And we'll see examples when you can do it multiple ways. Okay, but please read that for tomorrow. And then the last thing for today, the quiz next week. I think I did mention it before. The MCQ is going to be on everything we have done so far, from u substitution up to this partial fractions. It will be a mix. So quiz 1 to quiz 4 is going to be all mixed up, and I'm going to give you 10 questions on that. Okay. on what we've covered for that. Then the written part will be 2 questions, 2 integral questions on anything we have done so far. Okay, I will pick 2 questions from all of the tutorials you've done up to now, and you'll get that for the written part. Both of them will have been seen. You've done it before if you did the tutorials. Okay. Okay, and then that will be in preparation for the class test. Okay, because that's the following week, right? So here we've got, just to show you the time. So here we are. So you're going to have the quiz here. Next week, after that, that's the test. Okay, so please, right, it's right around the corner. 1 more week, and then the test. The stuff we do next week will not be in the test. The stuff we do Thursday, that will be the very last thing for the test. Okay, next week on improper integrals, that will be for class test 2. Please do not stress about that for the test. Okay, any questions? Well, good. Okay, see you tomorrow.